Hello, dear student. Myself, Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan, District Jalna. Today we will see Mechanics Properties of Matter and Sound, B.Sc first year, semester first, course code number PHY 101. Now, see some basic formulae that is based upon the chapter number 1, Mechanics. Now, first formula, that is period of compound pendulum, T equal to 2 pi into under root of k square upon L plus L upon G. Now, second formula, that is a Newton's law of gravitation, is given by F equal to G into M1 M2 upon R square, where G is gravitational constant and having the value of G equal to 6.673 into 10 raised to minus 11 Newton meter square per kg square, and M1 and M2 are the masses of the two particles or bodies, and R is the distance of separation between these two particles having the masses M1 and M2. Now, formula number 3 is here, that is a gravitational field due to a solid sphere having first point, that is outside the solid sphere. Gravitational field E equal to minus G into M upon R square. Now, second formula, that is gravitational field when a point inside the solid sphere, E equal to minus M into G square upon 2R cube into R. Third, that is point on the surface of solid sphere, E equal to minus M upon R square into G, where G is a gravitational constant. Now, formula number 4, that is a gravitational potential at a point from center of sphere, V equal to minus M upon R into G. Now, second, when the gravitational potential when point on the surface, that is V equal to minus M upon R into G. And third, that is gravitational potential at the center of sphere, V equal to minus 3 by 2 into G into M upon R. Now, first example, that is calculate the mass of the sun. Gives that the distance between the sun and the earth is 1.49 into 10 raised to 11 meter, and G equal to 6.66 into 10 raised to minus 11 in SI unit, and also here 1 year is equal to 365 days. Now, here in the problem we have find out the mass of the sun. So, here that is given quantities are here, that is G equal to 6.66 into 10 raised to minus 11 in SI unit, and also the distance between the sun and earth is 1.49 into 10 raised to 11 meter. Now, we know that mv square upon r equal to G into M upon R square. So, V square equal to G M upon R. Now, we know that V equal to 2 pi R upon T. So, putting the value of V here, we get 2 pi R upon T bracket square equal to G M upon R. So, from this m equal to 4 pi square r cube upon g into t square. So equal to 4 pi square upon g into r cube upon t square. So here also we know that here t equal to 365 into 86,400 second, that is a period. Now putting this in equation 1, we get m equal to 4 into 3.142 bracket square upon 6.66 into 10 raised to minus 11 into 1.49 into 10 raised to 11 bracket cube upon putting the value of t here, that is a 365 into 86,400, and after simplification we get the mass of the sun m equal to 1.972 into 10 raised to 30 kg. Now example number 2, that is calculate the gravitational potential at a distance 4 times radius of earth from its center. Assume that the earth is a homogeneous solid sphere. So here we have given, that is the radius of earth equal to 6,400 kilometer and mass of earth is equal to 6 into 10 raised to 24 kg, and g equal to, that is the gravitational constant, 6.67 into 10 raised to minus 11 Newton meter square per kg square. And here we calculate the gravitational potential using the formula V equal to G into M upon R. Now in our problem we have given M, that is capital M, equal to 6 into 10 raised to 24 kg, and also given the value of R is equal to 6,400 into 10 raised to 3 meter. So putting this value in equation V equal to G M upon R, we get V equal to 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 upon R, that is a 6,400 into 4 into 10 raised to 3, that is the value of small r. Now therefore V equal to 0.1563 into 10 raised to 8. Now therefore V equal to 1.563 into 10 raised to 7 joule into kg, that is the gravitational potential. Now next example, that is a sphere of mass 40 kg is attracted by a second sphere of mass 80 kg with force equal to weight of 1/4 milligram if their centers are 30 centimeter apart. Calculate the constant of gravitation. Now in our problem solutions, m1 equal to 40 kg and m2 equal to 80 kg. So and also given the value of r equal to 30 centimeter, that is equal to 0.3 meter. Also here given, that is a force equal to 1/4 milligram, weight equal to 1/4 into 10 raised to minus 6 kg into weight. So F equal to 1/4 into 10 raised to minus 6 into 9.8 Newton. So by Newton's law of gravitation, F equal to G m1 m2 upon r square. So putting the value of F here, 1 upon 4 into 10 raised to minus 6 into 9.8 equal to G into 40 into 80 upon 0.3 bracket square. So after simplification, G equal to 9.8 into 0.3 bracket square into 10 raised to minus 6 upon 40 into 80 into 4, and that is equal to 9.8 into 9 into 10 raised to minus 8 upon 12.8 into 10 raised to 3. So after simplification, G equal to 6.8977 into 10 raised to minus 11 Newton meter square per kg square. Now next example, that is assuming the Earth orbit around the Sun to be a circle. Calculate the angular velocity of the Earth about the Sun. What is the average linear speed and centripetal acceleration with respect to the Sun? And also orbital radius of Earth is equal to 1.5 into 10 raised to minus 11 meter. Now in example, here r equal to 1.5 into 10 raised to minus 11 meter, that is a radius of Earth, and also given t equal to 365 into 86,400 second. Now here we have find out the value of omega, that is a angular velocity, and also find out the value of v, that is a linear speed, and third, that is a centripetal acceleration. So we know that omega equal to 2 pi upon t. Now here omega equal to 2 into 3.14 upon 365 into 86,400 equal to 1.99 into 10 raised to minus 7 radians, that is the angular velocity, that is a omega. Second, linear velocity v equal to r omega. So v equal to 1.5 into 10 raised to minus 11 into omega having the value, that is a 1.991 into 10 raised to minus 7. So v equal to 2.987 into 10 raised to 4 meter per second, that is a linear speed. Now centripetal acceleration is equal to v square upon r. So putting the value of v square here, 2.987 into 10 raised to 4 bracket square upon having the value, that is r is here 1.5 into 10 raised to minus 11. So after simplification we get centripetal acceleration equal to 5.948 into 10 raised to minus 3 meter per second square. Thank you.